Dr. Atul Kumar Chauhan, sir, Honorable Pro VC, Dr. A.K. Srivastava, sir, and respected Director, Engineering, Dr. Vikas Mishra, sir. I, Dr. Preeti Kumari, on behalf of Amity University of Applied Science, welcome our today's guest speaker, Dr. Pawan Kumar, Assistant Professor, College of Horticulture and Forestry, Rani Lakshmibai, Central Agricultural University, Jhansi, India. So before starting, I would like to request a respected Director Engineering, Amity University, Jharkhand, Dr. Professor Vikas Mishra, to bless us with his words. Sir.
Thank you, Dr. Preeti. Am I audible?
Yes, sir.
Yeah. Okay. Good afternoon to one and all. It is my indeed privilege and pleasure to welcome Dr. Pawan Kumar on behalf of Amity University to this today's session. We are extremely thankful to you, Dr. Pawan, that you have taken out time to address on a very important issue on the role of the IT into the environmental management. As far as the topic is concerned, it is very relevant, and environment, as we all are aware, it's a very plays a very vital role in the nature as well as in our day-to-day life. And it is very fascinating, and it is very important also to manage the environmental issues in terms of how to address the different degradation factors, how to implement the different strategies. So it is very important that how we are making the conservation as well as the different effects which are being addressing the areas or affecting the areas of the environment is very important. So I am very much sure that today's talk of Dr. Pawan is going to be very beneficial, and it will make all of us understand that in what way the IT is going to play, or it plays a role in the conservation of environment. Be it remote sensing can be one of the areas where obviously which is being used to do the mapping or to understand the characteristics. So I'm very much sure that today all the participants are going to be benefited by the address of Dr. Pawan. Once again, I welcome Dr. Pawan on behalf of Amity University for this session and for this talk. And I extend my also wishes to all the participants, those who have joined today, to listen this very informative seminar on the topic of environmental management. Over to you, Dr. Preeti.
Thank you, sir. Now, before starting, let me take an opportunity to read brief profile of today's guest speaker, Dr. Pawan Kumar. Dr. Pawan Kumar has received the BSc degree in botany and MSc degree in environmental science from Banaras Hindu University, Varanasi, India. And he has done MTech in remote sensing from Birla Institute of Technology, Mishra, Ranchi, and the PhD degree from Faculty of Natural Science, Jamia Millia Islamia, India. His research interest includes climate change and coastal studies. He was a recipient of Innovation China National Academy Award for Remote Sensing. He has 27 H index and 69 I-10 index, and published more than 50 research articles in international journals, and authored more than 10 books in reputed national or international journals. He has teaching experience, and also we can include research experience in Banaras Hindu University, Kumaon University, Banasthali University, and Birla Institute of Scientific Research, Jaipur. Also, he has visited countries like Japan, USA, France, Netherlands, Italy, China, Indonesia, Brazil, and Malaysia for various academic scientific assignments, workshops, and conferences. He is a member of National Environmental Science Academy, India, International Association of Vegetation Science, USA, and Institution of Geospatial and Remote Sensing, Malaysia. Now, I would like to request Dr. Pawan Kumar to continue with his words. Over to Dr. Pawan.
Okay, Dr. Preeti, thank you so much for giving the opportunity to deliver the lecture in this conference. So now I am going to share my screen so that I can deliver my lecture on the basics of the space science or the remote sensing here. So now let's start the basic concept of the space science or the remote sensing. So the universe is the everything. It includes the space and all the matters and the energy that space contains. It even includes the time itself and of the course it include you also. So Earth and the Moon are the part of the universe, as are the other planets, and there are many more of the Moon also. So now let's start the So these are the Vikram Sarabhai. So Vikram Sarabhai is considered as the father of the Indian space program. He was a great institute of the builder and the establisher to the large number of the institutions are the diverse field. He was the instrument in the establishing the physical research laboratory in the Ahmedabad. So the Vikram Sarabhai Space Center, Thiruvananthapuram, is the principal center of the ISRO, responsible for the design and the development of the launch rocket and the technology. The center conducts the active research and the development in the area of the materials, systems, vehicle integrations, chemical compulsions, space weapons, structures, space physics, and the system reliability. The center with the design of the various missions. So the Aryabhat was the first satellite named after the famous Indian astrologers. It's some small things. Now, so these are the insect family that include the Indian satellite family. So these insect family include the insect 1, insect 3A, insect 3B, insect 2E, 2D, 2A, 2C, etc. So and this also includes the Kalpana 1 and the EduSat. So EduSat, these are the educational satellite program that is launched by the ISRO and that is governed by the Indian Institute of Remote Sensing, Dehradun. So these are the insect applications. So there are various applications of the Indian satellite, including the broadcast, communications, meteorological, others, and the some development. In the broadcast applications, they have included the television broadcasting, direct to home, that's called the DTS, TV, and the radio networking. In the communication, that is the VSAT connectivity, speech circuits on the trunk routes. In the meteorologicals, there are some meteorological imaging, data collection platform, and the disaster warming. And in the development, there are tele-education, including the health and the emergency communication. Apart from this, there are various applications, including the mobile services, search and the rescue operations, and the satellite navigation. So these all are the applications come under the Indian satellite, which are governed by the Indian Space Research Organization, right? So now next one is the now. So these are the Indian imaging system. So there are two missions. The first one is the polar mission and the second one is the geostationary mission. So in the polar mission 1979 we have launched the Bhaskara, Videocon, Samir. In 1982 we have launched the smart and the sensor based technology. In 1988 and the 1991 late we have launched the Indian remote sensing satellite IRS-1A and the 1B, including the IRS-1C and the 1D. So in the IRS-1A, 1B, there were two satellites, LIS 1 and the LIS 2. In 1994, we have launched the IRS-1C and the 1D again, and they have included the LIS 4 and the LIS 3. Apart from this one, in 2003, we have launched the IRS-P6 Resources 1 satellite, and these satellites are mainly help to forecast the agriculture activities. In 1999, we have launched the OceanSat for collect the information from the ocean. So apart from this, 1992, 93, 92, MESAT, INSAT 2E, INSAT 3B. So there are n number of the many more satellites we have launched one by one. So now there is some application part in the Earth observations again. So in the Earth observation satellites, so there is some agricultural activity, some soil activities, land, weather and the climate, ocean, disaster support, water, geological and the mineral, including the forest, environmental and the bio sector again. So in the agriculture and the soil, there are crop acreage in the production estimation, soil and the land degradation mapping, watershed development, horticulture mission for the North East. So these are the main fundamental application part under the agriculture sector as well as the soil sector. In the land, we have also planned for the land use and the land cover monitoring, watershed management, urban sprawl mapping, and the large scale mapping on the micro level also. Under the forest and the environment, we have just map of the forest, including the forest cover and the type map. Also, we have mapped the risk and assessment for the forest fire, biodiversity characterizations, and the environmental impact studies through the some Earth observation satellite. Under the weather and the climate, extended the range of the monsoon forecasting, regional climate model we have also included. So in the water, we also delineate the some watershed management under the disaster support, flood damage assessment, drought monitoring, and the landslide hazards. And in the geological and the minerals, we have just find out the coal fire studies and the some mineral exploration. So now, why we have started the ISRO? Why we have started the some space application part in the field of the this one? So when we have started our this mission like the ISRO or the NASA, so at that time we were the main 9 challenges. The first one is the in the future we will secure our the food security. So under the food security there is some precision farming and the evergreen revolution. So currently we are just doing the precision farming or the organic farming. Apart from this, the food security, we have also secured the energy in the terms of the energy crunches and the space solution. Then we have go through the environmental security through the global warming and the climatology. So these 9 great challenges are just beyond the 50-year back. So 50-year back, we were now able to think like that. In the future, we have to be the some requirement for the food security, energy security, and the environmental security. Apart from this, there were also the some resource security because the planetary exploitation is the main fundamental application or the some source of these challenges. Again, the next one is the space security because we assured in the future we have launched the n number of the satellite in the space. So at that time they are very crowded in the space. So we were very worried about this space debris and the space weaponization. Next one is the space transportation because we are just think about we have the some transport from the Earth to the other planet, like the some Earth to the moon or the some other. So at that time there were also the some changes, that is the space transportation. Now next one is the search for the life because we know our Earth has already passed the 4.6 billion. Already we have just back. Now the 0.4 billion years rest for the our life. So in the future it may be the Earth will be the destroyed. At that time we have searched for the life on the planetary hand or the alien civilization. Next one is exploring the origin and the evolution. And next one is the colonization of the Mars. So 1, 2, 3, 4, 5, 1, 2, 3 we have already achieved. Now next one is the space security or the space transportation, search for the life, exploring the universe, and the next mission is the colonization of the Mars. So these are the permanent habitat development because in the universe there are some 9 planets. In the 9 planets we have some hope on the Mars of the Jupiter. So our first hope on the Mars and the second hope on the Jupiter. So in this one we are next hope is the Mars. So in 2012 the Mars One project led by the Dutch non-profitable announced plans to establish the first human colony on this planet by the 2025. In the 2020 there was some COVID period. So in this COVID period we have lost the many pupils, but nobody can know in this COVID period we have lost the some scientific technology also because in 2020 there were a minimum distance between the Earth and the Moon, Earth and the Mars. And next after the 15 year or the 13 year, the next minimum distance will be the Earth and the Mars, because when we have launched any vehicles or the any satellites from the Earth, then it will reach on the Mars near about the 3.5 years, near about. So in the 2012, we have launched the some project that is called the Mars project. So the mission would initially send 4 astronauts on the one-way trip to the Mars, where they would spend the rest of their lives building the first permanent human settlement. So the Mars, in the first round, there were 100 people selected, including the 50 men and the 50 women, and with the 39 from the America, 31 from the Europe, 16 from the Asia, 7 from the Africa, 7 from the Oceania, and the 3 people from the India. So in this mission, there were the one-way mission, means in 2000, in the 2025 or 27, we will send the some people on the Mars for the period of the 9 months. After the 9 months, they will die on the Mars. They cannot come back on the Earth. So that is the first experiment that will be the held on the human being, because in the ancient time all the experiment was done on the animals, but it will be the first experiment that will be the held on the human being. So it will be the Mars colonization. So these are the space center. So in the India, there are n number of the space centers. So each and every state have their own space center, like the Jodhpur, Udaipur, Ahmedabad, Nagpur, Bangalore, Dehradun, Nai Delhi, Shillong, Hyderabad. So each and every state have governed by the central ISRO agencies, and these are the Indian Remote Sensing Global Network. So we have tie up with the n number of the countries like the Italy, Greece, Ecuador, Normans, and the many more. So these are the some collaborating institutes with our country. And next one is the Kepler's law of the planetary motion, because there were three law first, second, and the third, because the satellite are working in the same principle just like as the Kepler's law, because Kepler's first laws tell us orbit of the planetary body is in the eclipse like this one, and the second one is the lining joining planet and the sun swipe equal area in the equal interval of the time, because here you can see the speed of the any planetary body is the increase because the distance is the very large, and there the speed of the any planetary body is the very slow because the area is the very less. And the third one is the square of the time period of the rotation of the planets are the proportional to the cubes of their semi-major axis. So these are the Kepler's law that is governed by any satellite when we are launching the satellite from Earth to the any other planets or the universe. So these are the satellites. So now the question is, what is the satellite? It's simply heavenly or the artificial body revolving around the planet. It may be the moon, it may be the man-made satellite. Moon means that is the heavenly body, and man-made means that is the artificial body. So if you're talking about the type of the satellite, means the first one is the geostationary and the second one is the polar sun synchronous. So in the first geostationary, that is all the communication satellites, and in the polar sun synchronous, that is all the remote sensing satellites here. Now you can see here, these are the geostationary satellites and these are the sun synchronous satellites. So geostationary satellite are just seeing 1/3 of the all the Earth surface at a one time, and they are revolving with respect to the Earth, whereas sun synchronous satellites are revolving around the Earth from pole to the pole. Here we am just sharing the one video here, how satellites are revolving. Now see here, Earth are rotated from the west to the east, and our the satellite is just surrounding towards the our Earth, and the pictures is taken by in this way. See here, now the first round here, now the second round, now again third one is started from the here. So these are the swap period that is taken by the our satellites. Now the this one. So these are the push broom and the whisk broom. There was the two type of the sensor. So these are the geostationary and these are the sun synchronous satellite. Like the this one, from pole to pole, they are revolving around the our Earth surface. Now, so these are our swath, that is the one period from pole to the pole. Again, they are a second swath. Now again, there was the third swath because our Earth is rotating from the west to the east direction. Now, the third one is the, see, the first swipe, second swipe, and the third swipe. So there will be the n number of swipe that will all the cover of the space here, and these are the, when we have launching any satellite in the space, so there was some antenna here, and these are the solar planets. So they have just received the energy from the sun and resolve all the electronic circuit and get the captured the images and sent to the our any ISRO center or the NRC center. So in the Hyderabad NRC, National Remote Sensing Agency, there were some data capturing center. So there were NDC, means National Data Center Agency, that is captured by the NRC. So now again, we'll come back here. Now, so these are the launching. So these are the launching vehicle family. So in the ancient time, we will just launch the sounding rocket in the 1972. So after that, after the 5 year or 6 year, we have launching the SLV, and it is the carried the 40 kg of the weight in the circle of the low Earth orbit. So in the 1987, we have launched the ASLV, that is carry out the 150 kg, then Polar Satellite Launch Vehicle, that is carried out up to the 1000 kg in the Polar Satellite, that is the 93, and 2000 beyond we have launched the up to the maximum 2500 kg satellites, that is called the geostationary launch vehicles. Now, so now the next one is the, so these are the some basic of the some space science. Now just start the concept of the remote sensing. So what is the remote sensing? So it's basic concept of the remote sensing, that is the, in the layman language, that is acquiring the information without touching the any object or the without coming into the physical contact. So Earth observation from the space can provide the information to meet the meteorological needs, monitoring requirement, resource mapping, and the sustainable development. So apart from the satellite in the human body, there were also the some sensors, because sensor, it means as the getting all the information without touching the any object. The same thing in the our human being, there were three type of the sensors. The first one is the eye, the second one is the ear, and the third one is the nose. Eye, because we can see any object or the anything without touching them. We can hear anything without touching the any object or the anything, and we can smell anything. So these also type of the sensor that is inbuilt in our human being. So we can see any object between the 0.4 to the 0.7 micrometer, because beyond this energy we cannot see any object, because our eye responds to the EMR in the only the visible spectrum range, and these are spectrum range is the 0.4 to the 0.7 micrometer, and that is enable the three-dimensional visualization of our surrounding. So these are the main fundamental things of the EMR. So that is the principle of the basic remote sensing. So see here, you can see in this picture, there are some sun, some satellites, some forest, water, grasses, some bare soils, some paved road, and the some building. And these all are just surrounding to each other into the atmosphere. So see, the sun radiate the energy from the atmospheres on the Earth's surface. So during the Earth's surface, there is some teeny particle in the atmosphere. So there are two phenomena. Either the some incident energy incident on the Earth's surface, or they have distract from the, or they can distract into the atmosphere by the some tiny particle. So we will discuss later. So first, the sun radiate the energy towards the Earth's surface. So now they incident on the Earth's surface, and that energy received by the some forest, some water body, some grasses, some bare soil, some built-up area. So after striking on the ground, these energy reflect back towards the sensor or the satellites. So these energy captured by the satellites in the terms of the DN number, that is called the digital number, because each and every objects have their own specification. Either they have absorbed the energy, or they have radiated the energy, or they have passes through the energy. But these energy either the absorb or reflect or the transmitted only in the range of the some visible, only in the range of the some specific wavelength. Because if suppose they are a forest, so these forests have capability to absorb the radiations only within the, it may be the 0.4 to the 0.9 micrometer wavelength, or water body it may be the some limit to absorb or reflect the some wavelength 0.2 to the 0.3 it may be. So each and every object have their own specification in the reflect the energy only within the range of the energy. So they have reflect the energy, and this reflected energy captured by the sensors which is inbuilt into the, already into the satellite in the terms of the red, blue, green, NIR, SWIR, TIR, and the many more. So these DN value captured by the satellites, and through the software we can just read or interpret the digital number, because digital number is always the 8-bit resolution. So 8-bit resolution means 2 to the power 8. So the number will be the 256, but the digital number is only within the range of the 0 to the 255, because 256 subtract by the 1, because we are starting from the 0. So the range between the DN value will be the 0 to 255 instead of the 0 to 256. Now, so why we have started the remote sensing? What will be the next one is the, because with the help of the remote sensing we can map, we can identify, we can analyze everything which is much far away from the our Earth surface. So the main concept is the EMR, that is the wave concept of the electromagnetic radiations. Because in the wave concept there are two waves. The first one is the long wavelength and the second one is the short wavelength. So the long wavelength have the very low frequency or the low energy, and for the short wavelength that is the high frequency and the high energy. So frequency refer the number of the crest of the wave of the same wavelength that is passed by the point into the 1 second, and C is the velocity of the light, C is the light constant, V and the lambda, that is electric wave and the magnetic wave. So when we are talking about some electric wave and the magnetic field, then you can say if the electric field and the magnetic field, these two are the perpendicular, then at that time the direction of propagation of the waves are also the perpendicular on the electric field as well as the magnetic field. Because magnetic field will be produced because this electric field will produce the magnetic field, and this was the difficult to detect because the magnetic field produced by the changing electric field are the very low. Now, so the next one is the black body radiations. So black body radiation is the fundamental concept of the remote sensing. See here, these are the intensity and these are the wavelength. So all the black body absorb all the incident radiations for the particular given temperature. So see here, in the 4000 Kelvin, there are some reflected some energy. Up to the 5000 Kelvin, they have reflected some small peak. But for the 6000 Kelvin, they have just reflected all the energy that is concept of the black body radiation. So now the so now next one is the EMR. So what is the concept of the EMR? So these EMR include the gamma rays, X-rays, ultraviolet, visible, reflected, thermal, infrared, microwave, and the radio wave. Because when any radiation released from our sun, so that is the n number of the radiation, and so these radiation are the radio, micro, ultraviolet, X-ray, and the gamma ray. But these all are the rays beyond the visible limit, means 0.4 to the 0.7. So there are n number of the rays, but in between the but among these rays only we can see the visible range, that is the 0.4 to the 0.7, because our eye is very sensitive only for the range between the 0.4 to the 0.7. So beyond the 0.4 to the 0.7, either ultraviolet, X-ray, or the gamma rays, microwave, radio wave, or the thermal, we cannot see any ray. So these are the some main EMR under the visible spectrum. So if we are talking about the visible radiation and the thermal infrared radiation, so see here, there are two figures. The first one is these men are just surrounded by some black cloth, but in this one their hands are the visible, because when we are just sending the visible radiation on the any human being, at that time we can capture the identity but beyond the black body. But in the thermal infrared radiations we can detect everything, because these radiations are very sensitive towards the temperature. So these are the thermal radiation. So in the any rescue operation, either for the any terrorist or the any animals, so in the rescue operation we have just follow by the thermal infrared radiation, because these radiation can detect the human being releasing the temperature surrounding by the body. So that is the related with the perspective truth. So in the remote sensing there were some three phenomena. The first one is the wind rays just released from our sun. At that time their interaction with the atmosphere, the sun. The second one is the interaction on the earth surface, and the third one is the interaction with the satellites. So there are some three main phenomena. Suppose any radiations just released from the our sun, at that time before reaching on the ground they have interact in the atmosphere in the some tiny particle. So the first one is the interaction with the atmosphere. The second one is the when they have interact into the atmosphere, then they are fall on the our earth surface. So the interaction with the atmosphere, the first one is the second one is the interaction on the ground, and the third one is the interaction with the satellite. That is the third phenomena. So interaction with the atmosphere, so there are some three main phenomena. The first one is the scattering, second one is the absorption, and the third one is the reflection. So in the scattering phenomena there were a main three fundamental scattering. The first one is the raylight, second one is the Mie scattering, and the third one is the non-selective scattering. So in the first one is the raylight. So it occurs when the particle is the very small size compared with the wavelength. It means wavelength is the high and the particle size is the very small. So at that time, ray light scattering will be the happen. So these could be the particles such as the small specks of the dust or the nitrogen of the and the oxygen molecule. So in the atmosphere, if there were a n number of the oxygen and the nitrogen molecule, at that time this scattering will be the happen under the Mie scattering when the particle size and the wavelength both are the equal. For example, dust, pollen, smoke, and the water vapor are the common cause of the Mie scattering. And in the non-selective, at that time, particle size is much smaller than compared to the wavelength. Example, water droplets and the large dust particle can cause this type of the scattering. So the next one is absorption. So there is some three main atmospheric constituent like the ozone, CO2, and the water vapor. So the three main atmospheric constituents that which absorb all the radiation into the atmosphere. And the next one is the reflection. So some radiations are the reflected back to the atmosphere from the cloud, aerosol, and the water vapor, because they cannot reach on the ground. That is under the reflection phenomena. So these are the some atmospheric window here. So see, these are the transmission, and these are the energy, and these are the wavelength. So under the some specific wavelength, either energy they have totally reflected or they have totally some absorbed. So they have just show the some window like structure like the this one. See here, these are the window, again these are the window, again these are the window. It means into the this particular specific wavelength, these particle have absorbed all the radiation. On the specific this wavelength, these particle reflected maximum radiation into the atmosphere. So this phenomena called the atmospheric window. Now the second one is the interaction on the earth surface. So on the earth surface there are n number of the targets like the some trees, some rocks, some rivers, some settlements, etc. So interaction with the target, there were also the some two reflection. The first one is the specular reflection and the second one is the diffuse reflection. When the our earth surface is very flat or the some smooth surface, so in the smooth surface there were the some specular reflection, and in the diffuse reflection there is some rough surface like the some tree. See here, the rays are incident on the ground and they reflect back towards the sensors. So it's only one bounce, this one and the one bounce, this one and the one bounce. But in the diffuse reflection, the rays are incident and they are the bounce back in the multiple direction. So these are the 1, 2, 3 and the 4. So these are called the diffuse reflection. So when any EMR incident on the any object, so either they are reflect the energy towards the atmosphere, or they absorb the some energy, or they transmit the some energy. So the principle is says what, I is equal to R plus A plus T, means the total number of energy is equal to the total number of reflected energy, total number of absorbed energy, and the total number of the transmit the energy. So now these are the spectral reflectance of the various object. How we can identify or how we can just assessment of the any object, because each and every objects have their own specific properties. See here, these are the wavelength and these are the reflectance in the percentage. So these are the some blue lines, these are the some here red lines, some black lines, some yellow, and the some purple line. So in the yellow lines, so these are the clear lake water bodies and these are the some turbid water body. So in the clear lake water body, so they have reflect the energy only between the 0.4 to the 0.8 micrometer. When the our body, when our water is very turbid at that time, this wavelength is just increasing towards the 0.9. It means कि 0.8 or 0.9 beyond this wavelength our water body cannot reflect the any radiation. The same case for the our vegetations. So for the vegetations they have reflected the maximum energy, but 0.75, 1.3 and the 1.9 on this wavelength they have maximum absorbed energy at that time. Now the this one, and for the soil, for the silk part they are reflected from the 0.4 to the 2.5. So with the help of the wavelength and the reflectance we can identify each and every object, either the crop for either for the crop forecasting or the some crop monitoring or the some any object identification here. So if you're talking about the component of the remote sensing, so there were the three components. The first one is the platform, the second one is the sensors, and the third one is the data products. In the platform, that including the vehicles device on which sensors are the mounted. In the sensor system, the device which sense the energy either reflected or emitted by the target object. And in the data products, information received from the sensor package as per as the user requirement. So if you have the some requirements, or the if you want the some data at that time, you have to just receive the energy as per requirement from the satellites, or because in the universe there are n number of satellites and each and every satellites have their own specification or the some own targets. So on the behalf of the your requirements, you can go through the satellite specification for getting the satellite data. So what is the working principle of the data receptions by the sensors? So the two main fundamental of the principle, the first one is the cross track scanner and the second one is the along track scanner. So in the cross track scanner, these, so see here, these are the some motor, these are the rotating scan mirror, and these are the detector. So these mirrors are rotating from one place to the another place, again come back on the same places, again they are moving this directions, again they are moving in the that direction. So the angle suspended by the ground resolution cell, that is called by the instantaneous field of view, and angle suspended by the from one point to the last point, that is called the your angular field of view. It is also called the swath. These are the your swath, and these are the scan line direction. So it is called your cross track scanner. Now the second one, a long track scanner. So scan direction in only one direction, either this one. It means because the focal length is just away from the lenses, and these lenses capture the data when they are scanning in the only one direction. So cross track scanner scan in the one direction from the north to the south, but in the a long track scanner they are just scanning the line at just in front of the you or the satellite. So these are the your data representation. When we have captured the data from when we have captured the data by the satellites, so these captured the data have the only black, blue, some gray lines, some boxes. So these are the 1 pixel. Now the this one, because when you are taking the pictures from the mobile, at that time your pictures are just grouping of the some small boxes, right? So these small boxes are called the your pixel. So any pictures or the any photographs just are group of the some pixels, and these pixels are the some, they have the some numbers. This number, it may be the 170, 238, 0, 255, 17, 136, 68, because these digital number are the 8-bit resolution. 8-bit means 2 to the power 8, and the number, the range between the this one is called the 0 to the 255. See here, maximum number is 255, and these are the white color, and the minimum number is the 0. It show the black color. Means the black color means they have absorbed all the radiations, means they cannot reflect any radiations towards the sensor. So the value will be the 0. See here, 255 means that is the white color. It means they have absorbed all the radiations towards the sensors. At that time our digital number will be the 255, right? So these are the some pictures that is taken by the satellite. But when we have received the data from the satellite, that is not in the this much way, because when we have received any data from the satellite, at that time these are the raw data, and these raw data in the terms of the 010101 in the form of the binary number. So with the software we can import the data, we can import the this binary data into the some extendable supported software data, that is called the your .img. At that time you can see the this type of the photographs like that, and when we are just grouping this photograph, then we can get the this type of the number. Because just take the example, there were two mobile. The first one is the 1 megapixel and the second one is the 5 megapixel. So we have go through the 5 megapixel because the pictures taken by the 5 megapixel is will be the more clear than compared to the 1 megapixel. What is the reason behind it? Because 1 megapixel, that is called the 1 into 10 to the power 6 pixel, and the 5 megapixel means that is the 5 into 10 to the power 6 pixel. So when we suppose if these are our screen, and in this screen the 1 pixel, 2 pixel, 3 pixel, 4 pixel, 5 pixel and the 6 pixel, it means when these screens are just made up of the 100 pixel, at that time clarity will be the something, and when this screen is just made up of the 1000 pixel, at that time clarity will be the more. It means the more number of the pixel will be the more just getting the some pictures, and when the pixel will be the very less, at that time your clarity will be the very less. So go through the high megapixel for getting the higher image. So now these are the some platform. So in the ancient time we don't have any satellites, we don't have any technology. So remote sensing is essentially studying interaction of the EMR with the different object. It may be the some land, water, and the atmosphere. So in the ancient time, we don't have any satellite or other technology. So we were started our career in the field of the space science in the form of the balloon. So in the balloon, we have just mounted the some camera in this one and taking the pictures from the atmosphere. After the some time, we have just improved our technology and we have just landing on the kite. So in the kite, we have just mounted the some camera and just flying the kite into the atmosphere and taking the pictures from the kite on the earth surface. Now again, we are just developed again and just come back on landing on the pigeon. So in the pigeon, we are just set the camera or the lenses or their body, and when they are flying into the atmosphere, so they are taking the pictures from one place to the other places, and then again we are landing on the gladiators and then some flights and we are here on the satellite. So see here, from this one to the this one there are a huge number of the journey. It means we expend the many much more year from journey from one place to the another place. Now we are capable, now we are able to get the pictures from the universe either up to the 4 kilo, either up to the 400 kilometer, 600 kilometer, or up to the maximum 36,000 kilometer from the our earth surface. Now, so if you're talking about the remote sensing, so in the terms of the remote sensing, there are a two main fundamentals remote sensing. The first one is the active and the second one is the passive remote sensing. So in the active remote sensing means कि they have their own sense source of the energy, means कि they have created the energy on the atmosphere on the earth surface and then again come back to the received energy, means he threw the energy on the target object and sense the reflected energy. For example, camera with flash or the radar. Because ancient time we don't have any technology, we have some camera with the flash. So at that time we have generated the energy, we have generated the EMR towards the object, and after incident on this particular EMR, and then when they have reflect back towards the us, then we have captured the photograph. Radar is the same thing. The second one is the health sensors, means कि no personal source of the energy, means कि they have depends on the other source of the energy. So passive sensors are working only in the daytime instead of the night time, because in the daytime the source of energy are the sun, and these sun are release the energy towards the earth surface, and then these earth surface reflected the energy towards the atmosphere and the capture by the satellites. For example, our human eyes, ear, and the nose, and the camera without flash. So these are the some active and the passive sensor. For example, in the classroom, there are two type of the student. The first one is the active and the second one is the passive. Active means कि they have read their own material, study material. It means कि they are the very active. They are not a depends on the other student. And the passive means कि they are a very lazy, or they are depends on the active students or the some other, because they don't have any study material in the examination. So they are the passive. Active means कि they have their own source of the materials. They don't have depends on the other. So these are the active and these are some passive. Now, if you're talking about the some fundamental concept of the satellite, because in the satellites the some pictures are visibly as not in the their own colors, because in the false color and the true colors. So in the remote sensing the concept applying through the true color composite instead of the false color composite, because in the satellite the forest appear as the red color instead of the green color, because these are the electromagnetic band here. So these band are the blue band, green band, red band, and the NIR band. Again here these are the assigning color blue, green, and the red. For example, in the ancient time when in the ancient time we are taking some a TV example. So in the TV monitor there is some CRT gun, means cathode rays tube gun. So in this tube there were three guns. The first one is the red, second one is the blue, and the third one is the green. Because when we're talking about the primary color, so only three primary colors are the red, blue, and the green. And with the help of these primary color, we can generate the new secondary color, that is the magenta. The second one is the cyan, and the third one is the yellow. So the primary color is the blue, green, red, and then secondary color is the magenta, cyan, and the yellow color. So with the help of these primary colors, we can generate the n number of the colors, and these colors are the 2 to the power 256, means 2 to the power 256 type of the colors we can form in this particular earth. Because in the universe there are no any concept of the colors. Just thinking, in the universe there are no any colors, but on the earth surface we can generate the 2 into 2 to the power 256 type of the color. So these dice company are just doing the concept of this particular assigning color. So when electromagnetic bands, blue color are the passes through the blue color, green band passes through the green color, and the red band passes through the red color, then true color composite will be the form. But in the remote sensing, when we are green band passes through the blue color, red EMR band passes through the green color, and the NIR band passes through the red color, then false color composite will be the form. That's why in the false color composite, forest appear as the red color, because in the forest vegetations reflect the maximum NIR, and these NIR passes through the red color. That's why our forest appear as the red color on the false color composite. So if you're talking about the resolution, because resolution is the main fundamental pillar. So resolution is the defined as the ability of the system to provide the information at the smallest discretely separable quantity. In the terms of the first one is the area, means that is called the spatial. The second one is the wavelength band, that is called the spectral. The third one is the temporal in the terms of the time, and the fourth one is the radiometric in the terms of the radiation quantity. So if you're talking about the spatial resolution, means key, that is the discriminate the smallest object on the ground, that is called the your spatial resolution. Means if suppose any satellite have 0.5 meter spatial resolutions, means they have identified the up to the maximum 0.5 meter or the centimeter object on the ground. And if you're talking about the spectral resolution, means is sampling the spatially segmented image in the different spectral interval by allowing the spectral radius of the image to be the determined, and the radiometric in the terms of the bit number. The more bit number we will get, the more radiometric resolutions. And temporal means obtain the spatial or the spectral data from same point after at a time interval. So temporal resolution is also called as the repeativity of the satellite in the case of the some satellites. So these are the images to develop the application part, because here you can see these are the satellite image. So if you take the satellite image, and these are the processing and the analyze. So with the help of the some creating the thematic map, we have generated the table and reports, and with the help of these map sub attribute tables, we have some solution for our development in the terms of the crop productions, forest management, urban growth, landslide mapping, flood management, drought monitoring, mineral targeting, marine resources, and there are n number of the application part that's come through the remote sensing and the GIS. See here, effect of the different band. These are the your pan data, pan chromatic, that is the blue and black and white, And these are the your color data, that is the your multispectral data. So the same data, if you're taking the one band, it will be the show the black and white, and if you're taking the different band, then it will show the some colors. So these are the night arrives between the Europe and the Africa, the pictures taken by some satellite. And these are the Black Sea. Black Sea doesn't mean it show the some black color, and these are the some Red Sea. So these are the pictures from the satellite data, and these are the your some glacier region. See, these are your timberlines here, and these are the your Mount Everest. Now the this one here, like that, and these are your Google Earth images. That is our Parliament House, like this one show, and these are your Connaught Place of the New Delhi, just like the some circular structures, and these are the Rashtrapati Bhavan. Now the this one, and these are the your some trees, and these are your railway track, because each and every lines are the parallel to the each other, and these are the world view data. So these are the smallest fine data that is captured by the world view satellite, and these data spatial resolution are the 0.42 meter, means you can identify each and every vehicles on the ground, and also you can count the windows of each and every building, because they have just capture the data on the ground up to the maximum 0.42 centimeter. And these are the aerial photographs of the some Tokyo city. So these are the our basic principle of the remote sensing. Now we have the some can we take the some more time for the 10 to 15 minutes? Hello.
Hello.
Can we
Yeah,
take
yeah,
the
sure. Yeah,
time?
sure. Yeah, sure.
Okay. So now, so the second one is the GPS. So it will just take the 10 more minutes. So if you're talking about the history and the mapping of the surveying, so about the 5,000 years ago, the Babylonian produced the property descriptions and the simple property maps on the stone tables. And about the 2,000 years ago, Greek and Roman survey and the map their new settlement with the great degree of the precision, using the method that changed the very little up to this century, because the first known surveying by the ancient Egypt used to the re-establish property corner destroyed by the flooding of the river Nile. So it was the our just started the time when this Nile river destroyed the our whole cities. At that time, we were started the surveying and the mapping, and these are the some classical method for the surveying, like the triangulation, like the some chain, some tape satellites, some compass, some total station, and the some digital level and the GPS. So if you're talking about the GPS, so it consists of the all the weather space based navigation system developed by the United States Department of Defense to satisfy the requirement for the only military forces to accurately determine their position, velocity, and the time. So in the 1973 early, Department of Defense US decided to establish, develop, test, acquire, and deploy the space-bound global positioning system, and that will the results that is called the Navastar GPS. So see here, these are the GPS constellation. So these are the our Earth surface. So around Earth, there is some ring-like structure like the this one here. So in the Navastar GPS, there are 6 rings, 1, 2, 3, 4, 5, and the 6. And in each ring, there were 4 satellites. So 6 multiplied by the 4, that is the 24. It is the basic number. So in the 24, 21 satellites are the continuously working in around our Earth, and only 3 satellites are in the inactive phase. Suppose in any reason any satellites are not working at that time, the inactive satellites are just started towards the active mode and they are replaced the inactive satellites. So these are the GPS constellations around our Earth surface. So if you're talking about the GPS, so it's only the system today which is able to show our exact position on the earth anytime, anywhere, and the anywhere. So for getting the exact position on the earth in the terms of the latitudes and the longitudes, we are required the minimum number of satellites are the 3. But if you are taking if you are required latitudes, longitudes, as well as the altitudes, at that time minimum required number of the satellites are the 4. So minimum 4 satellites are required for getting the 3D positions, and minimum 3 satellites are required for getting the 2D position. So 3 parts. The first one is the satellite, receiver software, and the ground control station. So if we're talking about the GPS, so GPS satellites transmit the 2 frequency, L1 frequency and the L2 frequency, with the help of the 2 code, P code and the CA code. So we cannot detect or we cannot decode the P code, precision code, but we can easily decode the force acquisition code for the any country. So GPS have the 3 main fundamentals: Navastar, that is launched by the US; GLONASS, that is launched by the Russia; Galileo, that is launched by the European United. So in the Navastar GPS, there are a fully operated in the 93, and these consist of the 24 to 32 satellites in the 6 orbits, and they have mounted above the Earth surface up to the 20,180 kilometers. For the GLONASS, there are only 3 rings, means 3 planes, and each plane there are 8 satellites. So total number of satellites are the 24, and they are just below towards the Navastar, and up to the maximum height that is governed by the Galileo, and these are the operated by the European Space Agency, will consist of the 24 active and the 3 spare satellite. So if you're talking about the space segment, so in the GPS there are 3 segments. The first one is the space segment, the third one is the control segment, and the fourth one is the user segment. So in the space segments, 24 in the space segments, these satellites are the mounted in the control segment. So these are the 6 main control station that is situated in the Ireland, and within this one, the one master control station that is situated in the Colorado Spring. So Navastar, that is governed by the GPS, GLONASS, and the Galileo. Like so, in the GLONASS, that is launched in the altitude, and these satellites were intended to work for the weather position, velocity measuring, and the timing anywhere in the world. So these are the one part GLONASS M that is launched in the 2003, and it is inbuilt with the GIS mapping of the receiver, whereas GLONASS and the GPS. So GLONASS is launched by the Russia, whereas GPS launched by the United States, and coding through the some FDMA and the CDMA, because in the ancient time they were a mobile inbuilt with the CDMA mobile, and the current time that is we have launched the FDMA. So number of satellites that is governed by the 24 and the 34, and these both are the operational phase currently, GLONASS and the GPS, right? So now China is developing its own satellites that is consist of the 34. It is called the Baidu Navigation Satellite System, and is under the construction since the January 2015, and now it is the working and globally available by the current 2020. But our India have developed its own our satellite, that is the GPS. It is called the IRNSS, or the Indian Regional Navigation Satellite System, and these are our main system, and this system would be the consists of the 7 satellites, out of which 4 are the already placed into the orbit and project expected in operation by the 2016, and it's the currently in the working. So there are n number of the application of the GPS. So the first one is the navigation and the position. So with the help of the GPS we can navigate or we can identify the position of the any object. Route navigation system through the GPS. These are the some route navigation that is absolutely depends on the precision of the GPS. We can also use in the precision farming, because precision farming can be defined as the gathering of information dealing with the spatial and the temporal variation within the field. So with the help of the GPS and with the help of the some remote sensing, we can identify the some crop or the some disease crop. Now in the military we have also used the GPS for the navigation, tracking, bomb and the missile guidance, rescue operation, facility management and the map updation for our country. And in the navigation we have also used the GPS. So in the Gulf War 19 and the Kargil conflict 1999 we have used these GPS. And by the tracking we have also used the GPS for the tracking in the any military purposes or the some any common purposes. And these are the bomb and the missile guidance. We have also used these GPS through the multiple launches rocket system vehicles using in the GPS. And these are the rescue operation. So in the rescue operation we have also used our GPS technology. So these are the some fundamental application of the GPS and the remote sensing. I hope you can understand these are some basic principles and the some application part. Now it's over. So Dr. Preeti.
Yeah, that's really amazing. I, on behalf of Amity University, Jharkhand, would like to express my sincere thanks to Dr. Pawan Kumar sir for delivering such a wonderful online guest lecture on role of information technology in environmental management, basics of remote sensing. Thank you, sir, for presenting such a...
Preeti, Preeti, sorry, if any questions towards the from the student sides regarding this one application of the remote sensing or the some career inbuilt in the space science or the some remote sensing. So now you can say ask me.
Okay. Okay. So, is anyone who wants to ask some question regarding the topic? So, we don't have any questions right now.
Okay.
So, we can continue with the vote of thanks. Thank you, sir, for presenting a very interesting topic for all students of Amity University in simplest possible manner. I feel all of us who attended this session would be able to extract the best result out of it. Even we, the faculty members, were enlightened by this informative lecture. Once again, I would like to thank you, sir, for having spared your precious time for your consent and sharing your knowledge with us. We hope more such interactions with you in future too. I would like to thank respected Director Dr. Vikash Misra sir, respected HOI Dr. Joyita Chattopadhyay ma'am, and all the members of Amity Institutes of Applied Science for their constant support in organizing this online lecture. And I would like to thank all the Amity University family to provide me with an opportunity to organize the event. Additionally, a special mention to our IT team for their support and a special thanks to our students for showing their curiosity and patience during this session. Thank you, sir.
Okay, thank you so much, Dr. Preeti, for giving the opportunity to deliver the lecture in front of the students. Thank you so much. And if in the future, if you want the more lecture on the space science, now you can contact me anytime. Thank you so much.